Here we define the multiplying a vector by a scalar. Multiplying a vector by a positive number change the magnitude, not its direction. If we represent it by graphically, here we take a vector A. If we multiply its vector by two number, then it increase its magnitude, not its direction. So here we represent the vector 2A. Here 2 is a scalar quantity. Now we discuss the addition of vector. In the addition of vector, we can add two or more vectors. So here we write we can add two or more vectors graphically by placing each of vectors so that the tail of each vector is located at the tip or head of the preceding vector. Here we also represent the graphically how we can add the two vectors. Here we take the vector A. If we add the vector B into the vector A, we add the tail of the vector B to the head of the vector A. So here we add the two vectors by head to tail method. Now we draw the resultant of the vector draw such that tail of the first vector and head of the last vector. This is represent the resultant of the vector. So this is the vector A and this is vector B. So resultant vector we can get that by adding two vector A and vector B by using head to tail method. This is how we add the two vectors. Now we subtract the two vectors. Here we take the two vector and subtract two of the vector. Here is the vector A and this is the vector B. Now how we add the two vector, now how we subtract the two vector. First we opposite the direction of the vector B. When we reverse the direction of the B, it's represented by minus B vector. Now add two vectors. Here we take the A vector. We add the two vector by using a head to tail method. Here we add the second vector minus B vector to the head of the A vector like that the head is attached to the tail of the B vector. Here we add two vector by using head to tail method. Now we draw it resultant. We know that resultant it get by adding start from the tail of the first vector and head of the last vector. This is the resultant vector R. So here we get that the resultant vector R that is equal to A vector minus B vector. So here we write that in the diagram above, the difference between A vector and B vector is found by adding the opposite vector B to A vector. This is how we subtract the two vectors. This is called the subtraction of vectors. Now here we write how we multiply a vector by a scalar. The result of scalar multiplication is also a vector where the magnitude of the original vector is multiplied by the value represented by a scalar. If we multiply the scalar by positive number, so here we write scalar is positive number. Scalar is positive number. The resultant vector the resultant vector is in the same direction as the original. Here we take the vector A. If we multiply this vector by 2, that is the scalar quantity, then it increases its magnitude, not its direction. It has the same direction. Now we take the scalar, that is the negative number. Scalar is negative number. When the scalar is the negative number, when the scalar is negative, the resulting vector is in the opposite direction to the original vector. Let's suppose here we again take the vector A and multiply by its negative number. This is the vector A. If we multiply by negative 2, then it increases its magnitude, also it reverses its direction. So here is the opposite direction of the vector A when we multiply by its negative number. This is how we multiply the vector by a scalar number. If the number is scalar, if the number is positive and negative.